Welcome to everyone who's joining us. We're so happy to have you here. We're going to get started in just a minute, but Craig has an awesome presentation planned for you guys. I can't wait to hear it and for you guys to be able to hear this awesome information. So it is 1 o'clock. I'm going to hand it over to Craig. So thank you, Craig, for being a Stormwater Awareness Week presenter.
Thank you so much, Rebecca. Welcome, everybody. I'm going to start quickly. My name is Craig Kalagi. I'm the Sustainability Manager for San Pasqual Valley Soils. And we're going to be covering, I've worked a lot with compost and green infrastructure over 10 years. I was originally the technical director for the Western United States for Filtrex International, who pioneered the use of compost for stormwater management. And today's topic is going to be tools and tips for creating green infrastructure using compost. I currently reside in the San Pasqual Valley Agricultural Preserve. That's the largest agricultural preserve owned by a city, the city of San Diego, in the entire United States. It's 14,000 acres. And we farm about 75, not 75, I'm sorry, close to 375 acres there. And we are a compost producer, and we are connected with the Frank Conine Dairy, which has been there for over 60 years. It resides in, it's the last remaining dairy in all of San Diego County. You can see the year it was established in 1962 by a Dutch family, and Frank Conine is a descendant of that family. And as such, we are the only producers of a cow manure compost as well as landscape compost that we take in from the green industry. We do not take in any food waste or curbside. Basically, our products are either manure-based or clean landscape-based compost. If you want to know more about the company and the different products we make, here's the website. You're welcome to do that at your leisure. But what we're going to get right into the presentation, which is, let's start by defining what we mean by green infrastructure, because we throw a lot of terms around. But this is from the Wikipedia folks, and they have a nice definition I like that says, it refers to a network that provides ingredients for solving urban and climatic challenges by building with nature. The main component of this approach includes stormwater management, climate adaptation, the reduction of heat stress, increasing biodiversity, food production, better air quality, and sustainable energy production, clean water, and healthy soils. However, the EPA has a little different mix. They get a little more specific. They describe green infrastructure as uses vegetation, soils, and other elements and practices to restore some of the natural processes required to manage water and create healthier urban environments. At the city or county scale, green infrastructure is a patchwork of natural areas that provide habitat, flood protection, cleaner air, and cleaner water. Hopefully you can. So with that said, let's now look at the topic, which is what are tools to help create that kind of green infrastructure? If we know what we're talking about here, what tools are available? Well, you can go to the Cal Recycle Toolbox website and look up Compost and Mulch Use Toolbox. And there's the link. This is a fabulous, extremely extensive collection of resources on compost use best management practices. And there's even, when you first log on, you'll see a webinar there that actually describes it. But I'd like to look a little further into best management practices, because to truly be best, these practices must be sustainable management practices. And what do we mean by SMPs then? Well, that's the practices that meet our present needs without compromising the ability of future generations to meet their needs. And it requires a preventative and proactive approach, environmental design and management, rather than reactive end-of-pipe solutions. End-of-pipe meaning just in time. We aren't proactive. We're not designing for stormwater management and green infrastructure. We're reacting to what Mother Nature throws at us. Compost as a sustainable management practice. Let's look at that. Biomimicry is the foundation of any sustainable management practice. It's what would nature do, and an approach to environmental problem solving, product innovation, and site design solutions is truly sustainable management practices. It's typically no waste. Biofiltration and water absorption are key to this approach and this kind of design requirements. Post-fire remediation would be an example of how you can use these sustainable management practices to mitigate the effects of wildfires here in California. Green infrastructure, habitat creation, and native plant and animal maintenance, biodiversity, and restoring natural carbon cycles such as carbon sequestration to try to rebalance the amount of carbon we have in the atmosphere. So let's look at this a little bit from a natural nature perspective. If you look at nature and you look at the way the soil is built, organic matter on top, topsoil, subsoils, groundwater, and bedrock, this is what we are trying to mimic when we put into practice sustainable management practices. Now, if we look at a example of natural, let's say a forest, and we move towards a more urban environment from left to right, what you start to see is that not only does our pollution load go up considerably as we impair the ability of the soil to function as a filter. And so from forest to pasture to suburban to city, our pollutant load goes up, particularly as it affects rain events and stormwater management. Now, we have natural capital in our environment, and that's the stock material within the environment that we rely on to provide a steady flow of services necessary to maintain our economic, environmental, and human health. And that's by C.F. Jordan in his publication, Working with Nature. So compost is a natural capital. And why compost is so important to our survival? Well, there is no singular solution to declining soil and water quality, but the most promising tool that we have at our disposal for the task is, believe it or not, recycled organic matter. And the most versatile organic material is a certified compost. Now, compost utilization permits the watershed manager to actually leverage the power of the soil and water connection. We're going to be talking about that. But let's first look at what's in compost. If not all compost is created equal, it is a category, not a product. It's a mixture of organic matter, as from landscape waste, food waste, animal manures. Depending on what your feedstock is, it dictates what the compost is. And it's decayed and digested by organisms, and it should be laboratory tested to meet the minimum standards of quality and is used to improve water filtration, infiltration, soil structure, and biology. So we're not just guessing at what's in there. We actually have the technology to be able to tell us what's in there. Now, when it comes to sustainable management practices and green infrastructure, you have two tools at your disposal as it relates to compost. You have, if it's a quality compost, typically you're going to have coarse material on the left, and on the right, a finer material, usually 3/8 to 1/2 inch diameter in size. It's produced through the screening of the compost, which after the process of grinding and composting, you typically have a mix of coarse and fine, and a blend of the two is typically called medium. While the coarse is designed for filtration and hydraulic flow, and the fine is designed for water absorption and plant growth, and is extremely effective as a biofilter. Now, looking at the coarse filter media, typically you have some standards such as pH, which is anywhere from 5 to 8. Typically, you don't want to get much higher than 8. You're running into a lot of alkalinity in that case. Particle size, 60% of the filter media, the coarse, will be somewhere in the 1 to 2 inch range. The rest will be smaller than that. And then it's typically composted to remove pathogens and be free of weed seeds. Now, nature's filtration system is humus and organic matter and naturally produced compost that has been and this has been well documented in the scientific research literature, as an effective pollution filtration device evaluated for sediment reduction, absorption, and adsorption. Those are two different things. Ab means within, ad on the surface of. And so both on the surface of this compost, you have a lot of attachment going on of contaminants, as well as its ability to absorb and hold water. And this makes it an extremely effective filter media. And this is a picture of what it looks like. And then we can place it into a geotextile mesh to be able to move it, and becomes a portable berm that we can place in the flow of water for sediment control, for inlet protection, for check dams to slow that water down as it courses down a landscape, and as slope interruption to slow down the flow of water down slopes. So that is one of the most common uses of using a tool, a mesh, to contain that compost and contain that berm and place it in the flow of water to remove contaminants as a biofilter. So another tool, however, is the compost blanket. A compost blanket is actually a layer of loosely applied composted material placed on the soil. In, for example, a mulch. It is, in fact, a mulch in a disturbed or undisturbed non-vegetated area to reduce stormwater runoff and erosion. It's typically no more than a 1 to 2 inch layer. If you get much thicker than that on a large slope, it'll actually absorb so much water like a sponge, it'll actually slough off and run down the slope. So typically you don't want more than 1 to 2 inches. And it is an erosion control sustainable management practice that's actually focused on the source control rather than the sediment capture and filtering after the fact. So this is what a good material for a compost blanket looks like. And it supports the creation of green infrastructure. And it does so by mimicking nature. Another name for green infrastructure is low impact development, or LID. So you'll hear both terms used interchangeably. US EPA typically likes to use the term green infrastructure. But notice how this material, compost stormwater blankets, impacts every aspect of stormwater management, erosion and sediment control, and restoration and remediation of a landscape simply by the use of this material. And tool number 3 here is how you apply this material. Without a good technology to apply it, it doesn't become very practical. And so blower trucks and blower toe-mounted units are essential for the use, and a very important tool you need to consider for all kinds of applications. Here's an actual toe behind a smaller unit for tighter spaces. They come in trucks. They come in many different sizes. Finn and other companies produce and make these products. They're available all through the United States. So let's take now, and we're going to go to an actual case study here where we see how this is done. Here's a typical slope of loose, unstabilized soil that we need to somehow or another protect from erosion. And here is a blower truck application. You can see the hose and the 2 gentlemen on the slope applying a 1 to 2 inch blanket of this fine material. They added seed to it as they were blowing it, and this is the actual material 6 to 8 weeks after installation. Here it is 5 years after the install. Notice the dense growth, really, really good green infrastructure. And there were some additional plants put in there, such as Queen Anne's lace, to stabilize it and add more permanent green infrastructure to this site. So that's an ideal situation. What about all these other options, such as stormwater blankets, such as this one here made out of burlap, where it's biodegradable, so that's good. But what will happen oftentimes is as the stormwater infiltrates that blanket, it starts to rail and channel underneath the blanket, and you do not have that intimate contact, and therefore you start to see erosion coming out from underneath the blanket or underneath the blanket itself. Compost has a very unique quality to it that when you blow it, in that fine material fits in all these little nooks and crannies on that rough soil surface, it makes intimate contact with that soil. And that allows us to get a really nice vegetated compost stormwater blanket. You can apply a blanket with just the compost, it'll do a great job. But there is absolutely no substitute for Mother Nature in generating a vegetated compost stormwater blanket. And that blanket of compost holds that moisture, supports the germination of that seed, and really stabilizes the underlying soil. So I'm going to show you an example of how we did this at a San Diego quarry site where they had been for years mining gravel. So this was a gravel pit, 400 feet high, 7 acres. And before we started it, we decided to apply the blanket and see what worked best and what seeds would germinate. And we had a large combination of different native seeds blown in with it. And what we found was that when we added coarse 1 to 2 inch, the filter media, a little about 20 to 30% to the fine compost on these slopes, it prevented that fine compost from running down the slope and sloughing off. And it supported a number of native plants. In this particular case, you can see the coarse material laying on top of the fine. The fine material held enough water and nutrients to get something to grow on essentially subsoil. So they decide to scale up to this full 7 acres. You can't see the gentleman, but he's on a harness hanging off the slope at about 200 feet up. There's a big blower truck unit on the base of the slope. And they blew a 1 inch, half inch to 1 inch with a wide variety of native seeds. And 1 year later, this is what we got. Now, keep in mind, this had supplemental irrigation. We were in the middle of a drought, so they applied supplemental water and would irrigate it on a regular basis. And so we got some pretty decent germination. Now, note that most native seeds don't all germinate at the same time. Many of them, in fact, you can see some native seeds will take years to germinate. So this was after year 1, though, and you can see how rocky and gravelly and how little topsoil there was for us to work with here. Here it is 2 years later, more seed germinating, a little close-up of it just to give you the coverage. And this is at 4 years after native vegetative establishment. It shows you the power of a 1 to 2 inch, even a half inch layer of this material with its ability to hold moisture and support that germination and vegetation of that native seed. Really quite amazing. Now, tool number 4 I want to share with you is a lockdown netting. Sometimes if you can't apply the coarse material with the fine, or you're going to, you want a nice smooth surface of fine 3/8 to half inch minus compost blanket, you can add a lockdown netting. It's a netting that acts like turf reinforcement netting. You lay it down first, then you blow on top of it. That locks the compost up into that netting and holds it in place. And that's really advantageous where you have steep slopes, 2 to 1 or even greater. This is a 1 to 1 cut slope, really steep, where you want to hold that material on, but you still want to be able to grow something there as well. And sometimes if it's an extremely windy canyon, you'll actually apply the lockdown netting on top of the compost, and apply it first, and then lay and I've even seen it done where they sandwich the compost layer with seed between 2 layers of lockdown netting just to hold it in place. But here it is, 6 to 8 weeks after install, 85% coverage. This was seeded with a nice native grass. Here it is 9 months later. And you can see how effective that vegetative cover is. And when you get that kind of vegetative cover with compost, you have a number of other benefits. Here's a research report by Dr. Britt Fawcett, University of Georgia, where he compared yard waste, that's the material we just looked at, a compost applied to a slope over 3 months, and then compared it to hydromulch and silt fence with seed. And notice how much better your blanket germination rate is with the compost versus a hydro seed and silt fence application. Now, again, keep in mind, this is one example. So site conditions certainly make a difference. Also note that the percent cover of weeds, because you have more vegetation, you have less weeds because the vegetation you seeded is out-competing the weeds. And so you have 20% weed cover in that versus almost 69, 70% after 12 months with the hydro seed and silt fence application. So that vigorous growth that you get with a compost blanket is really, really important in terms of the overall quality of the green infrastructure you're trying to establish. Now, in addition, that blanket also slows down, it absorbs like a sponge and slows down the water, increasing the infiltration. And you can see here the time to runoff is much greater with a blanket than it is with a hydro mulch and a silt fence because it's a much thinner layer and doesn't have the absorptive quality of a compost blanket. Well, what that results in when you go to the second slide down, that table shows the total solids lost. And you'll notice that where you have more a slower runoff time, where you got more absorption, you also lose much less soil. And so the total solid loss was the amount of soil that actually was coming off of that slope with the two treatments. And you can see how effective a compost blanket is in not only slowing down and absorbing and infiltrating, but actually holding that soil in place. Now, here's an example of that absorptive quality of a compost blanket. This was a 4-inch rain event per hour, 1 hour, 100-year storm. And bare soil was about 50% infiltration under these conditions. A straw mulch was blown on, that was about 60. And look at that compost blanket, the ability of it to absorb and infiltrate that heavy rain event, 84%. We're going to see some slides of a Caltrans project that demonstrate its ability on a 5-inch storm here shortly. So there are advantages to a compost blanket, as I've just shared with you. It's that intimate contact, we're just going to review it quickly, which allows nearly 100% ground contact, eliminating any puckering of other types of erosion control blankets and undermining of the soil beneath those blankets. It has that intimate contact, reducing the sediment loss as well. And water infiltration is increased, as we saw from the research studies, increasing germination from the seed. So you get a better germination and vegetative establishment. And then the water discharge from the slopes is decreased, reducing the potential sediment loss. And that was that last slide showing the solids loss just by decreasing the water discharge from that blanket. And then lastly, the addition of the organic matter improves that slope ability to revegetate and establish a permanent erosion control system, which is ideally what you want to do with a green infrastructure project. In addition, let's take a look at also its ability, a blanket compared to conventional seeding without compost blanket, on the quality of the total nitrogen, nitrates, phosphorus, soluble phosphorus, and sediment coming off of different slopes. You've got anywhere from 45% reduction in nitrate runoff, as high as 98%. Total phosphorus, which can be a real problem in receiving bodies of water, 83 to 99% on that. This blanket's ability relative, and this is comparing it to just seed and fertilizer applied to a slope. In one case, it was compared with hydromulch, and you can see even there, the improvement in pulling out these contaminants. And this is an important slide demonstrating that simply because you're applying compost doesn't mean you're increasing the amount of nutrients being released from that compost. And in fact, it's tied up, it's an organic form of nitrogen, phosphorus, and potassium. So it's locked in that organic matrix and very slowly released. And in fact, its ability to absorb water is actually what's resulting in this ability to filter these contaminants out and hold it in place instead of running off into our riparian habitats. So really important slide. And then you can combine it with the filter socks, and you can see in combination with a blanket, you can go after targeted pollutants, not only the nutrients, but E. coli, heavy metals, oil, and it's extremely effective at these contaminants. And you can add natural sorbents that adsorb to the surface of the filter media and is contained within that filter media, removing it from the flow of water and runoff. Very important tool and a very inexpensive solution for targeted pollutants. So now let's look at some actual case studies. And this is one that was a 2-year observation by Caltrans in Monterey County that I was a part of a good number of years ago. And this was the project. There were 45,000 cubic yards of compost covering 108 acres. It was a huge project applied to extremely erosive soils. Here's an example of a compost blanket with seed, and they use berms. So those darker lines up on the upper portion. This is one slope. This is not two different slides. This is one slope after following a 5-inch rain event in a 24-hour period. And the bottom portion of this slope that you see is bonded fiber matrix and fiber rolls, your conventional BMPs for erosion control. And under this extreme condition, it actually failed. And yet the blanket with the vegetation and the berms held fast with virtually no erosion occurring at all. It really is a great slide exhibiting exactly how effective these blankets can be. Caltrans did a number of other things. They put a compost blanket on and combined it with blown straw and then tacked it in with a tackifier. And you can see, again, really good vegetation, just another tool in the toolbox. Here's an example of seed with the compost blanket on the left. On the right, just the compost blanket, no seed. And then right in the middle, just untreated soil. And you can see the rilling that's going on, the channeling that's occurring, where you can see even a blanket with no vegetation did a beautiful job of absorbing that water and preventing any loss of soil. Here's an example of where Caltrans applied BFM on the left, and then they applied a compost blanket and then oversprayed it with a hydromulch with seed. And you can see even in this case, the BFM on the left with no compost failed. And you see a tremendous amount of rilling and channeling. Where on the right, that blanket absorbed that, and that bonded fiber matrix that was sprayed on the top held beautifully, allowing any seed that's in there to germinate and stabilize that underlying soil. Really nice example of a approach they use that they like. And then here's a compost blanket with hydroseed and coir netting. This is, again, using the hydroseed over the compost blanket and then covering it with coir netting, again, due to wind erosion and just stabilization. Coir netting is very, very popular as a biodegradable netting that you can lay on top of this to get optimum erosion control under extreme erosive conditions. And this is just an example of how much more compost, because of this kind of research out in the field, that Caltrans is using by design. And they also follow the U.S. Composting Council Seal of Testing Assurance Certification process. So all compost used in a Caltrans project requires this, and this is to know what's in that compost. This is that lab testing that I told you about earlier that's so critical to understanding the quality of the material and how it's going to behave in the environment you're using it. So let's look at Caltrans's recommendations real quick. Compost blanket with coir netting, very effective, aggressive erosion control material for large, steep slopes, and they install it right over the compost berms when they use the berms to hold the berms in place. Then you've got the compost blanket with a blown straw. Again, very reliable, was very cost effective, a little less expensive than the coir netting, obviously. And then erosion control material combination can be used in a variety of different conditions. They like to use that one. And then the hydroseed application. You apply under netting and over the compost to protect seeds and provide good germinating conditions. And so consider including seed in the compost application to reduce application steps and equipment. And then lastly, they also like to incorporate compost in soils. They'll usually rip the soil 2 to 3 times, or rip the soil, incorporated basically 2 to 3 times the depth of the compost applied. So for example, if they apply 1 inch of compost, they'll incorporate it 2 inches into that soil and then seed it for vegetative establishment. They typically limit this to slopes that are 4 to 1 or flatter, not quite as steep, to avoid any sort of sloughing or running off. And then their use of compost berms. They like to berm the material and use it as a linear sediment barrier on slopes in lieu of fiber rolls. It will outperform fiber rolls hands down. Now keep in mind the socks are a way of stabilizing that berm, and they like to use a 12-inch compost sock at the toe of the slope in lieu of fiber rolls or silt fence. Again, excellent at capturing any possible sediment that is being released from the slope. The 8-inch socks are used in swales and drainage ditches and are also used in place of fiber rolls for slope interruption devices. And then the fiber rolls can be used primarily for temporary sediment control, which is fine. But if you're going after green infrastructure, typically that's a permanent infrastructure application. So you'd be much better off going after something you can leave there and you do not have to remove after the fact. So in summary, these compost BMPs or SMPs is what I like to call them, accelerate the natural systems required to restore sites, build healthy soils by mimicking the natural environment, all the things we talked about, provide optimum vegetative growth, protect that soil surface from splash erosion. And they have this high water holding capacity, which slows down and disperses the energy of that sheet flow flowing over that slope. High carbon to nitrogen ratios result in a low discharge of nitrogen. So these are not contaminating the runoff with high levels of nitrogen. In fact, just the opposite. And they have a natural biofiltration characteristic, removing many contaminants that could potentially be present in that soil. Now we're going to go to real extreme conditions, and we're going to go to severe slope stabilization. And this is a site in Northern California, outside of Gilroy, actually, where there was a riparian creek that was used for salmon used it for breeding, and it was coming down. And this is an example of this wood, and oftentimes it's concrete, hard versus soil armoring. So this case study shows you an example of a site. There was a home up here on the top. You can't see it, but the first step in this process, before removing any of this hard infrastructure, this hard armoring, was to cover the creek. So underneath this plywood base is an actual flowing creek of water. And then they regraded and stabilized and produced a nice flat surface on that slope. And now you can see the house, and came in and created a stable foundation upon which to place some grow socks. So the grow socks are tool number 5 in our toolbox here, where we fill it with a growing media and add seed to the sock itself. Now, this is a sock that has 1/8 inch openings, and it's typically a grass that can grow through it, but we can also, as you're going to see, apply broadleaf plants by just cutting an opening in it. And we're going to soft armor that slope. And here's how we're going to do it. You're going to install tool number 6, which is a geogrid that is laid on the foundation of the soil and anchored in with gripple anchors or duckbill anchors to make sure it doesn't go anywhere, to secure that geogrid to the surface. And then you're going to take your 3-foot grow socks with growing media in them, compost. Basically, it's just straight compost, fine 1/2 inch to 3/8 inch minus material, but you can add other nutrients to it if you'd like. Normally, most people don't because the grass grows quite nicely in it. And they will start to install these socks on the slope, covering them with the geogrid and implementing supplemental irrigation. And I list that as tool number 7 because water is so important. And if you can apply supplemental irrigation to the growing media, so here he is stacking the socks 3 feet, they're climbing up the bank, and then wrapping it with the geogrid, anchoring it with gripple anchors, and then coming back in and cutting some small holes right with it. They try not to cut the geogrid. They just try to place the transplants in between that little square in the geogrid. And so they're planting broadleaf native plants in the sock as well. And this is what it looks like. So you can see some of the native plants that they've plugged in there. And keep in mind that this is completely secured with GeoGrid all the way to the top and then wrapped up there. And this is it 3 months later with the irrigation in place. And this is what it looks like after it's completely vegetated. And you can see the creek now flowing freely at the base. This is a fabulous example of habitat restoration, a biofilter, and complete stabilization using soft armoring. So here's what we started with, and this is what it looks like today. So another great example of how you can use these different products. The system that Filtrix deploys, and by the way, you can get all of these CAD drawings and technical specifications for everything I'm showing you on the Filtrix website under their technical data sheets that they have there. They provide them at no cost. So any engineers listening today, you can go to the Filtrix website and download all the specifications on how you can do this. Now I'm just going to close here with a few other things here in regards to the fact that we mentioned post-fire application of the compost blanket and how effective they are. I want to just show you one slide by Dr. David Crone from University of California, Riverside, where he did a 2-year study funded by Cal Recycle on the impact of compost on soil erosion and water quality following wildfires. And here's what he concluded after 2 years. Compost applications were very effective in reducing water runoff. On average, runoff volumes were reduced by 80% with these blankets. The compost applications are very effective in reducing soil erosion. On average, sediment and total dissolved solids and total suspended solids were reduced by 95, 65, and 94% respectively. So these are California condition research findings. Very, very impressive. I consider it a landmark study. Anybody that wants that study, I'll give my email address at the end. I will send it to you. I have it saved. I think it's one of the classic studies. I'm surprised more people aren't aware of how effective a compost blanket is in remediating burn sites. There's also a publication by I think it used to be Forester Press. I'm not sure who publishes it now, but it was a design manual for green infrastructure using compost. It's called the Sustainable Site Design Manual. All of those designs, by the way, are posted on the Filtrix website at no cost, but you can purchase this if you'd like. It's non-proprietary, and it just gives you the design specs for all the different applications you can use compost for. And then you've got the US EPA also has their fact sheets on the use of compost blankets, socks, and what have you. I'm going to close now by just summarizing what I've told you. And it's biomimicry and why it's important, because that's what we're talking about. And Dr. Carl Jordan, an ecologist in 1998, said, the closer we manage landscapes to their natural design, the more we save on energy, inputs, hard infrastructure, and financial expenditure. Working with nature takes advantage of the services that are both free and efficient when you work with nature. So biomimicry is the foundation of sustainable management practices. Always ask yourself the question, what would nature do? And an approach to environmental problem solving, product innovation, and site design solutions requires, to the best of our ability, no waste, biofiltration and water absorption, which support the vegetation of plants and habitat restoration. It also is extremely effective at removing contaminants from post-fire remediated sites. This green infrastructure is a habitat creator, and native plants and animal maintenance is encouraged and promoted to create this biodiversity that we want in that environment. And then lastly, restoring natural carbon cycles. When we talk about storing all the excess carbon in our atmosphere, this is the way you do it. So working with nature, I want to close with Nora Goldstein's quote. She's the editor. Her father started BioCycle many, many decades ago. It's just a phenomenal resource. If you've never check out their online publications. If you want to stay in touch with all the different research that's going on with organic, recycled organics, But she stated, and I just love this quote, the primary limitations on organic use are not technical. As you've seen, there have been over 20 years of research on these tools. If the watershed managers or landscape contractors become enthusiastic users of organics, the only serious boundaries will be the limits of their imagination. So many of these applications I showed you in the tools that we've come up with were a result of somebody just trying something and seeing if it would work. And lo and behold, working with nature does work. And it is the quickest way to rebalance our environment and get things back on track where they're out of balance. So with that, I'm going to open it up. I think we've got, Rebecca, about 15 minutes for questions. That was my goal. I know I went through a lot of slides, but I have 15 minutes to answer questions. And here's my contact information I'll leave up. So anything I showed you, if you want the research reports, you want technical reports on how to do it, spec sheets, whatever, please don't hesitate to contact me. I've got quite a library. Or you can go to the Calorie Cycle Compost and Mulch Toolbox, and you'll find it all there as well. Just a little harder to find because there's so much of it.
Fantastic. And if you have any questions for Craig, go ahead and put them in the chat while we start answering some of the first questions that came in. So Craig, we got several. The first one is, you mentioned manure-based compost, but also that the compost goes through laboratory testing and certification. Do you mean through USCC? Also, does the properly cured manure-based compost have any leftover smell?
Good question. First of all, I typically, for stormwater use, I typically do not recommend a manure-based compost because it is higher in nutrients. Okay, so almost everything I showed you is a landscape-based compost, high in carbon, low in, relatively low nutrients, particularly very low in nitrogen. And so it's good to test it, but we test all of our compost, including the manure compost. It is used extensively for the organic growing, certified growers in San Diego and the area. They like to use it because it has a higher nitrogen content, and some of the vegetables they're growing, as well as the tree crops and vineyards, are higher uses of nitrogen than some of the native plants. So the manure-based compost is tested on a regular basis, as is the landscape. Those are two different. Keep in mind, remember, not all compost is created equal. A manure-based compost, different feedstock, different nutritional parameters and characteristics. So it'll be a very different product than the landscape compost. And you can always, if anybody asks us for a technical data sheet on the test results, we have them available. In participating in the STA testing, seal of testing assurance program for the U.S. Composting Council, we are required on a quarterly basis to test this material and make that data available to anyone asking for that information. So we're glad to share that with anybody anytime they purchase our product. And that should be true of anybody that has an SDA certified compost. They should always make available these test results so you know what you're putting on that soil.
Perfect. And the next question is, I know you already touched a little bit on this, but we'll just go over it again, just to make sure we cover this question. Are there any studies comparing the effectiveness of the same thickness of compost and hydromulch, eliminating thickness as a factor?
There have been tests, as Dr. Brett Fawcett did studies like that. They don't, the hydromulch is going to be a thin layer, typically attached to the soil surface. It's usually a ground wood fiber with a tackifier, either guar or plantago. It's like well, the guar is a plantago, but you can also use something like psyllium. The psyllium is connected with plantago. It's a very slimy material, and I've often heard hydroseeders say they're sliming the slope. So it attaches and then dries and kind of glues the fiber and the seed to the soil surface. So it's not a thick layer. You can apply it more thickly if you want, but typically it's usually an eighth to a quarter inch, a half inch at most, where the compost blankets are going to be a half, 1 to 2 inches, considerably thicker, much more water absorptive, And you can use tackifiers even with compost. Typically, Dr. Fawcett always said he preferred not to see tackifiers used because it would potentially affect the absorptive ability of the compost blanket to absorb that water. And if you can control the volume of water on the soil surface of a slope, then you can, in effect, eliminate the runoff coming off that slope. Meaning, if a 1-inch rain event is absorbed, and San Diego State University, I've got the test results if you'd like to see them, did studies on compost blankets and on mulches. And on the compost blankets, a 1-inch rain event is absorbed by a 1-inch blanket of fine compost with zero runoff. And so if we have zero runoff, we have zero erosion, and we have zero contaminants coming off those slopes. That's how effective these blankets are. And that data is substantiated by studies from San Diego State University's Soil Erosion Lab. So glad to provide that data to you if you'd like to see it.
Okay, and we have another one. Is the sock made out of natural fibers?
The ones we were looking at there, particularly the black, where we're trying to anchor and really stabilize a steep slope. Typically, we're going to use a polypropylene mesh because we want the tensile strength to hold that slope in place. Remember, it's a soft armory. But what will happen is the vegetation will grow through and over that polypropylene, burying it literally, so it's not seen, and anchoring and providing even additional support to that slope so you don't get any future erosion or loss of soil. There is biodegradable mesh available, and Caltrans uses a lot of it, and it is designed for permanent infrastructure where you vegetate something, but typically it's designed to be left in place. And as long as you are assured that you're not going to get a major storm, the biggest issue with biodegradable is you lose your tensile strength of the fiber itself when it becomes biodegradable, such as it's made with wood fiber, cotton, and other materials. So those meshes quickly in contact with soil start to degrade. And as soon as they degrade, they lose that connection to the soil and anchoring it on, where the polypropylene, you can establish that with stakes or geogrid, and it's not going to decompose, and it's going to stay solid, strong, supporting flows of water, particularly along stream banks where you have a very strong force, shear force from the running water. You do not want to use a biodegradable sock under those circumstances where you have a heavy flow. It's ideal for sheet flow only, where it's going to be absorbed. It'll slow the water down, allow the seed to germinate, hopefully. In cases with Caltrans where I've seen the biodegradable, oftentimes they'll come in, they'll put it in before they landscape as a slope interruption device. Then they'll come back in when they landscape, cut the sock or just push it over because the bottom's usually rotted out, and cover it with compost and just leave it in there as part of the landscape mulch. And so the biodegradable sock eventually decomposes completely and is not removed from the site. So there are different ways to use these materials. The type of mesh you use is a tool, and biodegradable has to be used very quickly and judiciously when you apply it, because as soon as you place it down, if there's any moisture present, the mesh itself will start to degrade very quickly within weeks, and you'll lose that tensile strength and its ability to stay in place. I hope that makes sense. I've got information on biodegradable sock that I'd be glad to send anybody on test results by Dr. Britt Fawcett on how to handle that material and how it behaves under different conditions.
Okay, and the next question is, are the cost of blown compost and BFM similar?
I'm sorry, repeat that again, Rebecca?
Are the cost of blown compost and BFM similar?
No. It will cost you more to blow a compost blanket. And that's the reason why majority of slopes, people do use BFM almost exclusively, and we see very little compost blankets because it's the least expensive BMP. However, as you saw, the results are very different as well. And in many cases, what they'll find is they'll do a BFM application and have to come in with a compost blanket when nothing germinates or will grow due to very adverse soil conditions. So compost blankets are typically used in severe erosive soils like the one we saw with Caltrans up in the Monterey Bay, where we actually had failures with BFM. But honestly, BFM works most of the time and can be very, very effective stormwater tool. But is it the equal to compost? Absolutely not. You will not get anywhere near the environmental benefits, nor will you be able to get the habitat, the quality of habitat that you would get by applying a compost blanket and vegetating that slope, feeding that slope and those plants slowly as that blanket decomposes over time. You just don't. Most BFM, there are some that are now adding compost. So Profile has some good products where they're actually adding compost to the BFM to try to bring some of that biology into the soil.
Fantastic. And then another question we have is, and where can we source certified compost? It seems most landscaping material distributors locally don't know anything about certifications.
Correct. And that's when you purchase it from, let's say, somebody like San Pasqual Valley Soils, you request documentation that it is certified. And we actually have a certificate, seal of testing assurance that we renew every year and send to any of our customers demanding it. You're right. Most people don't know that you can get certified compost and that there's even a difference between a certified compost and one that may or may not be certified and you have no knowledge of what's in it. So that's a great question. And always demand that from your compost producers, that they provide some level of laboratory testing to tell you what's in that material before you purchase it.
Okay, and here's another one that just came in. If you're trying to do a compost blanket and all the STA compost producers can only furnish a fine particle size compost, would you suggest simply a thinner thickness of compost, say 1/2 inch thick, or something else?
Yes, that question, that's a Caltrans kind of question, because Caltrans, they like to use the coarse for the filter socks. They like to use the fine for blankets and for soil augmentation, amending. And then they like to blend the two, and that's a medium compost. And what I would ask the people that have the fine, if they can provide some coarse or acquire some coarse composted material, they can blend it, and Caltrans gives the ratios and you can produce it. But oftentimes, for example, when we grind our greens, we end up with a medium grade compost that's a blend of coarse and fine, which is perfect for slopes. And that is the case for a number of them. So they may actually, before they screen the fines out to produce a 1/2 to 3/8 inch minus compost, ask them if they have the compost before they screen it and that it's a blend of coarse and fine, and then have them test it with a soils control lab out of Watsonville, or there's other labs can do it as well and give you the ratio of coarse to fines, and that'll tell you whether you're a medium grade compost. And we are still working on that. That's a big issue right now with Caltrans, is finding that medium grade, because they have a lot of slopes and they like to use the medium grade. But the medium grade is no different than that slope on that high wall where we blended in 20 to 30% coarse with the fines. We actually created that medium grade in order to hold it on that hill. And that's what Caltrans is trying to accomplish when they ask for a medium grade compost. They're asking for particle size that will allow them to use it on a slope without it sloughing off due to gravity and runoff. Hope that answers that question. It's a little tricky because, again, we're evolving as an industry, and as more and more people start to utilize compost for stormwater management and green infrastructure, you're going to see more and more of these kinds of questions come up.
Okay, and it looks like we're just about out of time. So thank you so much, Craig, for presenting. And his contact information is on the screen. So if you have questions, feel free to send him an email.
Yes. And
Go ahead.
Rebecca, I just want to let people know we're also the official palletized compost sock manufacturer for Filtrex International for the Southern California region of California. So if you ever want to blow it on your own and you need to purchase mesh, you can purchase it through us as well. We'll sell you the mesh and you can fill it with whatever compost that you deem appropriate for your particular site conditions. And so we work closely with Filtrex International to make some of these tools that I shared with you available, as well as the technical data and specification sheets and cut sheets on how to use it and create these solutions.
Fantastic. Well, you're definitely going to want to save his email. So go ahead and either screenshot it or take a photo, copy his email down so that you can get in touch with Craig. If you have not registered for any of the other workshops, we have a couple of really good ones coming up, especially if you are California based. We have one at 3 p.m. Pacific time where we're going to be interviewing the water board about the regulations with the new 2022 permit that just came out and what that looks like for annual reports. If you tackled an annual report yet for construction, you'll know that it is very different than it used to be. So you're not going to want to miss that workshop because you get to talk with the regulators. And then we have an industrial stormwater treatment system workshop that ends the day at 4 p.m. Pacific time. So be sure to head over to stormwaterawareness.org and you can see all those workshops and register for them, as well as watch any that you've missed. So thank you, Craig, for presenting today, and thank you everyone for attending.
Yeah, thank you, Rebecca, for excellent job of moderating. Appreciate it. And thanks for your technical support as well.
Awesome. See you guys at the next workshop.